Hello guys, in this video we're going to talk about the homework 12.3 geometric sequence part 1, the level 5 plus. So first of all, you need to understand for geometric sequence, which means that the ratio between the terms is going to be the same, isn't it? So if we have the t1, the first term is equal to a, then the second term is going to be equal to the a times r, so that the third term is going to be ar squared. And all the way to the tn, the nth term is going to be equal to ar to the power of n minus 1. So that's the formula you should be remembered. So for the first questions, we have the fourth term and the seventh term of the geometric sequence are negative 54 and negative 1458. So first of all, as we have the fourth term, which is the t4, and the seventh term, which is the t7, is equal to these two numbers respectively, which means I can give two equations. So try to do it by yourself, and then let's see the answers. So first of all, we have our t4 is going to be equal to ar to the power of 4 minus 1, isn't it? And then the number is equal to negative 54. And then we have t7 is equal to ar to the power of 7 minus 1, equal to negative 1458. Then what we're going to do is to simplify first. So we can get the ar to the power of 3 is equal to negative 54. And then ar to the power of 6 is equal to negative 1458. The next step, we can try to simplify it. So this is the first one, this is the second equation. Then we can using the second equation to divide for the first equation. So if we do the 2 divided by 1, which means that we have ar to the power of 6 divided by ar to the power of 3, which means we left this r to the power of 3 is equal to negative 1458 divided by negative 54, isn't it? Then we can say that the r cubed is going to be equal to 27, which means that r is just equal to 3. So now we got the ratio, which means that we can substitute back into the first equation. So we substitute r equal to 3 into the first equation, then we can say 8 times 3 to the power of 3 is equal to negative 54, so that the a is equal to negative 54 divided by 27, and then you can get negative 2. So which means that the general term is equal to ar to the power of n minus 1, which is equal to negative 2 times r, which is 3, so 3 to the power of n minus 1. So that's for the first part. And then for the second part, we just do it here. So for the second part, we have the equation is the tk times t2k is equal to this huge number, isn't it? So try to substitute the things inside. We have tk times t2k, isn't it? So this is just equal to what? This is just equal to ar to the power of k minus 1 times ar to the power of 2k minus 1, isn't it? And this two things times together will give you negative, it's going to be giving you this 6-digit numbers, 236196. Okay, and then how can we simplify it? As we have the a is just equal to negative 2, isn't it? This a times a giving a squared, which is 4. And then the r is just equal to 3. So it's 3 to the power of k minus 1 plus 2k minus 1 is equal to 236196. And then we have this 3, and then we simplify the power of this part. So this is going to be 3k minus 2 is going to be equal to 236196 divided by 4. So what's that equal to? This number just equal to, let's use the calculator to get this, is equal to 59049. Okay, and then now we can using the log to the both sides. So we have 3k minus 2 log 3 is going to be equal to log 59049, so that the 3k minus 2 just equal to log 59049 divided by log 3. This number is going to be equal to 10. So we have the k just equal to, you move the 2 here, become 12. 12 divided by 3 giving you 4. So the k just equal to 4. So that's for the question 1. Now we can try to do the question 2. So we have to insert 3 numbers between the 4th and 4/81 such that 5 numbers form a geometric sequence. And then we have to find out the 3 inserted numbers. So which means that in between of this 4th, the quarter, and then we have a, b, c, and then 4/81, isn't it? So treat the whole thing as a whole sequence, then this 1 over 4 is going to be our first term. So we can just say that this is equal to t1. And then this is going to be our 1, 2, 3, 4, 5. So this is going to be our t5. Then as we have t1's formula and then t5's formula, so we can get the ratio, isn't it? So we can say that the t1 is just equal to a, which is equal to a quarter, and then t5 is equal to ar to the power of 5 minus 1, giving you the answer of 4 over 81. Now we can just substitute the first equation into our second equation to get this 1 over 4 times r to the power of 4 is equal to 81 divided by, it's going to be equal to 4 over 81, isn't it? So we move the 1 over 4 to the right-hand side, becomes times 4. So we have r to the power of 4 is equal to 16 divided by 81, which means that the r just equal to, so the r just equal to 2 over 3, isn't it? So what's the next step that we can do? But try to bear in mind that this is r to the power of 4, which means that the r can be actually positive or negative either, isn't it? So this one can be positive 2 over 3 or negative 2 over 3. Is that okay? So for next step, we can just say that the Tn can be just equal to a r to the power of n minus 1, giving you that the a is 1 over 4, and then the r is going to be 2 over 3 to the power of n minus 1. So which means that we can just substitute and then to find out these three numbers. But double check if this is the positive ratio, then the three numbers is going to be positive. And if this is a negative number, which is a positive number, negative, positive, negative, and positive, isn't it? So both of them is okay. So for the first one, so when the r is equal to positive 2 over 3, which means that the a just equal to 1 over 4 times 2 over 3, giving you the answer is 1 over 6. And then the b just equal to 1 over 6 times 2 over 3, giving you the answer of 1 over 9. And then for the next one, for the c is going to be equal to 1 over 9 times 2 over 3, giving you the answer of 2 over 27. So we try again to double check times again the 2 over 3 is really giving you 4 over 81, which is the same as the fifth term. And then for the second combination, which is when the r is equal to the negative 2 over 3, which means a and c is going to be the negative numbers, so giving you negative 1 over 6, but b is going to be the same because times another negative giving you positive, so we have positive 1 over 9, and for c is going to be negative 2 over 27. So we have two groups of the answers. Okay, so that's for question 2. So for question 3, we have this is known as the an and bn are the general term of two kind of the geometric sequence, and then we have to find out the following general terms. The corresponding sequence is a geometric sequence as well. So as we have the an and bn is geometric sequence already, so we can say that the an can be writing as the a times r to the power of n minus 1, isn't it? So for the bn, is going to be equal to b times s to the power of n minus 1. Is this okay? So for the next part, we just to try to think about this part. So we have the a is an times bn squared. So which means that an we can actually writing as ar to the power of n minus 1 times bs to the power of n minus 1, and the whole thing squared. So this is going to be equal to a squared b squared r 2n minus 2 times s 2n minus 2. Then as the power is going to be the same, so as the power is the same, so which means that this is equal to a squared b squared times rs to the power of 2n minus 2. And is this going to be a geometric sequence as well? So first of all, if we want to be a geometric sequence, which means that the Tn should be equal to AR to the power of n minus 1, something like this, isn't it? So our A, or we can just change another format, we can write it as the star, and then times a circle to the power of n minus 1. That's the format what we want. And then the star is going to be a number, so now a squared b squared is actually a number, so we can just say this is actually just our star. But our power now is n minus 1. It's not we want is n minus 1, but the power now is 2n minus 2. This means that is wrong. It's not, because we can change it to a squared n squared times rs squared, and then the outside to have this n minus 1 power, isn't it? Because the 2n minus 2 is actually equal to 2 times n minus 1. And then we group this 2 to the power of rs. So we just think about this whole thing just equal to the circle. Okay? So that we can say that the an times bn squared is a geometric sequence with the first term t1 is equal to a squared b squared. And then the ratio is equal to r times s squared. So that's for the part A. Then to do the part B, I should move this page to a little bit, maybe this part. Okay, so now we can try to do our part B. So for part B, we have an divided by bn minus 1 is an bn plus 1. So as again, we should just substitute the whole thing inside our formula before. So we can say an divided by bn plus 1. This is going to be equal to an just equal to arn minus 1. And then what we have for bn plus 1, so we substitute our n becomes n plus 1. So the answer we have is bs to the power of n, isn't it? And then what we're going to do here, then we can say this is equal to, as what we want is still something like this, a number times another numbers to the power of n minus 1. So that's how we're going to do it. So as you can see now, this is n minus 1. That's something what we want, isn't it? This is n minus 1, but here we don't have the n minus 1. So how can we do that? If we give them an n minus 1, give them an n minus 1 here, which means that we have to times another s. To balance the whole thing becomes back our denominator, isn't it? Then we can combine them to say that this is a over bs, and then we times r to the power of n minus 1 divided by s to the power of n minus 1. As again, as the power is the same, so we can combine them, so it becomes a over bs, and then we times r over s to the power of n minus 1. So which means that the an over bn plus 1 is the geometric sequence with the first term t1 is just equal to a over bs, and then the ratio is going to be equal to r over s. So try to see again, this is our a r to the power of n minus 1. So any sequence with this pattern, which means that is actually a GM.